How's it going, everyone? And in this video, we're going to be diving deep into custom VPCs and subnets in AWS, and we'll jump into it. So basically what I'm doing is I'm going to be walking through all of the steps to create our own custom VPC. We're going to make a public subnet. We're going to also make a private subnet, and then we're going to be putting resources like EC2 instances inside of these public and private subnets, so we can see how we're able to use route tables and internet gateways to control who can access these things and what these things can talk to. So we'll jump into it. So basically we're at the AWS console home right now, and what I'm going to be doing is first going to VPC. So you can click it here if you don't see it, or you can just type in VPC, and we're going to click on this guy right here. And the cost of making your own custom VPC is nothing. It's for the resources that you use that you will get charged for. But for our purposes of just this demo, don't worry about it. So we're going to click on Create VPC. And I'm going to, for the sake of an introduction to all this stuff, because we're not going to know what all this stuff is right now, we're just going to create just a VPC right now. And I'm going to call this the VS Custom VPC, like that. And then it's going to ask us a CIDR block. So basically inside of our little virtual private cloud, we are going to say what are the allowed IP addresses for this thing. And so CIDR blocks are basically shorthand notation that is used to, in one line, define a range of acceptable IP addresses. So in my case, what I have is this. So I'm going to say 10.0.0.0/16. Basically, the 16 means that the last two octets can take on any value between 0 and 255. So the range of this CIDR block will be this. So 10.0.0 to 10.0.255. So this will be 255 squared number of possible, or 256 squared number of possibilities. So that's how you can get several thousand IP addresses you can spin up inside of your little virtual cloud. It is important to note, though, that AWS reserves 5 IP addresses when you make these things. So just make note that not all of them will necessarily be usable. And so we're going to do that. So I'm just going to put this to the side. And so we're going to stick with that little CIDR block. So basically we're saying that inside of my VPC, every single resource is going to have an IP address, an internal IP address of something in that range that we've just defined. And so tenancy, we're not going to change any of these defaults, and we're going to keep our name tag as the custom VPC. So we're just going to click on create. It's super fast to do this, and that's great. So now that we've got our own custom VPC created, what we want to do is we want to logically group subsets of this overall bucket of IP addresses into their little groups, and so that's why we have subnets. So we're going to then click on subnets right here under the VPC dashboard, and you can see that AWS has already put some things in here for the default VPC that they give you, and they have got default subnets. So what we're going to be doing is we're going to be creating our own subnets, because we need to create our own subnets for that custom VPC that we just made. So the first thing we have to do is tell it what VPC we want to put these subnets in. So this is where I'm going to say, yes, I'm going to be wanting to attach, or this subnet will be associated with this custom VPC that we just made. And then from there, we're going to give this subnet a name. So in my case, I'm going to call one of these the public subnet, so VS public subnets. And then in terms of availability zone, this is where you have to be really careful for a demo. If you're going to want to have a public subnet and a private subnet, you're going to want to make sure that they are associated with the same AZ. So in my case, what I'm going to do is I'm going to say that we're going to keep this to the AZ called US West 1A. And that's in the US West 1 region, but we need to make sure that we keep AZ constant. And the next thing we're going to do here is I'm going to say that I want my CIDR block for my public IP addresses to be the following. And so basically what that's going to do is going to say if a resource is inside of this public subnet, it will have an allowed range from 10.0.1.0 to 10.0.1.255. Again, AWS takes some of those, takes 5 of them from you, but still gives you a fair number to play with. So this is exactly 255, or 256 minus 5 is 251. So you'll have 251 IP addresses in this subnet that you can use. That's the limit of the number of instances or other kinds of resources you can have inside of that. So we're just going to check all that stuff. I'm going to say cool. And I'm also going to add in an additional subnet we are attaching that to the same VPC, that custom VPC that we've made already. And again, literally just going to do the same set of parameters here. So I'm going to have a private subnet and the AZ. We want to make sure that we're going to keep this AZ consistent. And the other thing is we want to have the CIDR block. And so this one is going to be literally exactly the same thing as the first one, except the third octet is going to be prefixed by the number 2 instead. So that's how we're going to make sure that our subnets do not have overlapping IP addresses, because if they do, that's when you'll get errors, because your subnets are supposed to be holding unique subsets of IP addresses in your overall VPC. And again, we've got our name tags. That's great. So now we're going to click on Create Subnet. And so just like that, very quickly, we've now spun up a public and a private subnet inside of our custom VPC. So the next thing we're going to want to do here is I'm going to open up the EC2 dashboard, and we're going to try to launch an EC2 instance into our public subnet, because that's the whole point of controlling all this network access stuff. So we're going to go to Launch Instances, and I'm going to call this VS Public Instance, and I'm going to stick with the free stuff, AL2. I'm not going to change the architecture, not going to change the instance type. I'm going to create a little key pair. I'll just call this, KP1 because we're original. And it's going to download it locally to this computer so we can connect this thing through, PowerShell, SSH stuff. We're not going to be doing that. We're going to be using EC2 Connect. But it is good to have a copy of that for your own records. Now this is the important part. So under network settings, we're going to click on edit, and so by default, it's assuming that you want to put your EC2 instance into this default VPC that AWS has already created for you in your account. We don't want to do that. We want to be using this custom VPC. And when we choose this custom VPC, you can see that it's now showing us the 2 subnets inside of it, and the subnet that we want to put our public instance into, assuming we want this thing to be able to receive traffic from outside of our VPC, we're going to select the public subnet. And you can also see this auto assign public IP address thing here. You do need to select enable for that, because we do need to have a public facing IPv4 address for this EC2 instance that we're spinning up for it to actually work. And then the other thing here is under firewall or security group rules, we're going to be creating a new thing here. We're going to be needing to allow SSH traffic, because how else are we going to connect to this thing? And then in addition to that, we're going to need, because it's in our public subnet, we're going to say that it's allowed to get any type of source traffic from anywhere. So that's basically saying like anyone can connect to this thing if they have access. And so very liberal policy for our security group. And I'm going to keep the storage the same, and we're not going to change anything under advanced details. And then we will click on Launch Instance. So we will give this thing a moment, and we can click on View All Instances, and you can see that this guy is getting ready to spin up. So I will let this thing take its time, and then we'll come back to it. Cool. All right, so we now have our EC2 instance up and running inside of that little public subnet that we've created for our custom VPC. If we click on this instance ID, we can see that it's got an IPv4 address, which is great. And then you can also see that its private IP address is 10.0174, and that's because it is inside of that range of IP addresses that we want for our public subnet. So this block right here, so things are looking the way we expect them to. Now, if we go and click on this connect button right here, we're going to get a rude awakening when we try to actually connect to this guy. So, everything else is the same default stuff. And when we hit connect, it's going to, or it should throw us an error. And you can see that it's just spinning right now. Yep, so we have issues with the network, and why, you may ask, is because we have not done anything to resolve, or even though we've called it public subnet, we haven't given it a way of actually talking to anything outside of that subnet. So even though the security group itself for the EC2 instance is allowing traffic from anywhere, the overall subnet that it's living in is not able to talk to anything outside of our VPC. So that's why we can't even connect to it from this computer through EC2 Instance Connect. So to resolve this, what we're going to do is we're going to go back to the VPC dashboard in AWS. And what we need to do is we need to create this thing called an internet gateway. And so basically the internet gateway is this thing that will sit between your subnet or your VPC and the internet. And so the internet gateway allows traffic to enter and leave from the internet to your VPC. So for your public subnet, if it needs to talk to the internet, it's going to have to do it through this internet gateway. And right now there's only one internet gateway, and that's attached to the default VPC that AWS has created. So we need to create an additional internet gateway for our specific VPC. So I'm going to call this the VSIGW. That's the shorthand for internet gateway. And then we're going to click on create. And you can see that once we create this thing, it's in a detached state. And that's because we haven't told it which VPC it should be associated with. And it's also important to note that your internet gateways have to be uniquely one-to-one mapped to a VPC. So one gateway to one VPC and vice versa. You can't have one internet gateway for multiple VPCs or anything like that. Next, what we're going to do is we want to click on actions here, and we're going to tell it we're going to attach this to a VPC. And you can see that it's able to see that custom VPC that we've created. We're going to then click on attach internet gateway. And so now we've enabled our VPC to have traffic exchanged with the internet. So if you're thinking that's fantastic, now let me connect to my EC2 instance. There's one more step we need to do here, but I'm spoiling things a little bit. So we're going to go back to this guy. I'm going to click on here, and we're going to try to connect. And we're going to again try to run this EC2 instance connect thing. And again, we're going to get hit by an error message or a timeout because we have yet to actually define a route table. So the route table will be what allows inside of your VPC the public subnet that you've created to talk to the internet gateway. Because right now, even though the public VPC is inside of your is inside, and it doesn't actually know of the internet gateway, so we need to tell it about that. So what we're going to do is we're going to go to internet gateways. What we're going to do is we're going to go back to the VPC dashboard, and then under the left pane right here, they have this thing called route tables. And what we want to do is we want to create a new route table, and we'll call this the VS public route table. Just copy that, and we're going to say that this guy is going to be affiliated with the custom VPC that we've created. And then I'm going to click on create, and that's great. And then in addition to that, I'm going to make another route table for the private subnet that we have. So this is just for the sake of organization. So I'm going to go again back to route tables, create route table, and we're going to call this the private route table and attach this to that custom VPC just like that. So now we've got all these guys active. So what we want to do though is inside of this public route table that we have, we're going to click on that route table ID. And then what we need to do is we need to say that in addition to traffic inside of our VPC being able to talk to anything local, it also needs to be able to talk to our target internet gateway that is specific to this VPC. So we need to click on edit routes. We're going to click on add route, and then we're going to say basically anything is going to have that target of the internet gateway. So internet gateway, and it's going to find that internet gateway that we've just created. And so again, just to summarize what this new route is going to allow inside of our route table is it's basically going to say that when something inside of our public subnet, inside of my custom VPC, wants to talk to a destination that is anything, that's what this 000/0 CIDR block means. So any IP address outside of this thing, it's going to first go talk to the internet gateway that we've created to do that, because the internet gateway is inside of that VPC to get us that internet access. So then we hit save changes, and so now this is looking great. This is our public route table again, and the whole reason why we've defined a specific public route table is that inside of our private route table, we do not want to have this policy, because that's the whole point of having a private subnet, is that you're isolating your resources from the internet. If you have super, private or confidential things running on it that you can't expose to external sources, or you don't want to run the risk of having someone hack in and then be able to easily export them to some server somewhere else. This is one of the security steps you can take. But yeah, so we've set up our public route table that is on top of our public subnet inside of our VPC successfully now. So now when I close out this guy and we again try to connect to our instance, we should be able to make it all the way through. Okay, so I am troubleshooting this and I think I've found out what the issue is. So if you go to EC2 instances and then we're looking at the specific instance here that's supposed to be public, when I click on networking and we go to subnet ID and we click on this guy, it takes me to the VPC management console. And then when I click on this subnet ID itself and I view the route table, what I'm seeing here is that the route table for this public subnet is currently only showing to allow traffic to local. We still apparently haven't actually added in the ability for it to have routes to that internet gateway, which is the reason why this guy's still airing out on us. So what I'm going to do is just go back to the VPC management console, route tables, public route table, and this target should be good. I wonder what this guy will do. Maybe it'll help us. But it should reflect that it has these routes. Subnet associations. That is what I didn't do. I never actually associated the subnet with the actual route table. So my mistake. So what we need to do is we need to click on Edit Subnet Associations. And we're going to then click on the public subnet that we have here. We're going to click on Save Associations. So now we've successfully associated the route table with the subnet inside of our VPC. So now when I go back to here and I go back to my instances section right here, click on this instance ID, click on Connect, and then we click on Connect again. This should let us in and we're in. So a little bit tricky, but thank you for bearing with me. We have now successfully made it all the way in, and we can like echo hello world. And we can also, apparently doesn't like that. It does not like it when I pass in the exclamation point, but whatever. Basically what I want to do is we've successfully connected to our instance that is running inside of our public subnet, and we've created all this stuff from scratch. We're also going to try pinging google.com, and we can see that we are getting successful response. That means that our EC2 instance that is living inside of our public custom subnet inside of our custom VPC is successfully able to make it to Google and back. So that is awesome by going through the route table and through our internet gateway to get out of that VPC. So that is awesome. So stay tuned, and in the next video I'm going to walk through how we can set up stuff in our private subnet and control access to it through Bastion hosts. So stay tuned. Thank you all for watching. Let me know if you have any questions, and I'll talk to you guys next time.